Hi, good day to all. I am Krishnaraj, Assistant Professor from the Department of Automobile Engineering, Hindustan College of Engineering and Technology, Coimbatore. In this video lecture, I'll brief you about the electronic vehicle management system that includes an vehicle management system as well as an engine management system. Nowadays, an electrical and electronics architecture in commercial vehicle has the diversity of options for controlling the vehicle management as well as for the engine management system as a function of vehicle management system, and then as a function of engine management system. It has a variety of electrical and electronics plays a vital role, because in earlier days we have only an mechanical components. So we have mechanical components for controlling the entire vehicle and engine management system. Suppose if you are taking an engine management system, it doesn't have an electrical and electronics in very earlier days. So it has a mechanical type of injectors, mechanical type of pumps. So like these kind of things are exist in the earlier days. For vehicle controlling systems also, like if you are taking in braking system, suspension, steering system, whatever may be. So in those days they don't have any electrical and electronic systems, so that only it is somehow it is difficulty to control the vehicle management system, and we cannot able to achieve the maximum output of power in the engine. So nowadays, so they are included, it is assisted with the electronics and electrical systems along with the automotive systems, so that only we can able to achieve the maximum power of the same size of engine. So nowadays also we have an same sizes of engine, but we can able to achieve the maximum of power, sudden acceleration, deceleration, maximum BHP, everything we can able to achieve by means of this electronics for controlling the vehicle management system also. So we have an automatic braking systems are there. So automatic braking system that automatically applies the brakes without the driver's knowledge. If any obstacles present in front of the vehicle when the vehicle is in motion, so if detects means automatically applies the brakes. Likewise, so we have an ABS anti-lock braking system is there, electronic stability program is there for controlling the vehicle management system, for controlling the vehicle stability and lane departure warning. So if the vehicle is running on the straight pathway, if the lane is dislocated means it gives an alarms like that. Then blind spot detection for parking areas, blind spot areas it will be detected, and the driving assistance like in adaptive cruise control systems. If your vehicle is running for prolonged kilometers, then the adaptive cruise control system is given for the driving assistance. Not only for that, for driving alert, driver's alert also it is assisted with the electronics. The driver's conditions is monitoring in the vehicle itself. So if driver is sleeping or not, everything is monitored by the electrical and the electronics. So the electrical and the electronics plays a vital role in the automotive system, so that only now we can able to achieve this position in the commercial market. So thing is, so it has some varieties of complex structures, so for controlling the engine and vehicle management systems. So for controlling the engine and vehicle management systems, that includes an ECUs and sensors, sensorical data, storage, CAN systems, everything that are includes. So it has a main 4 thrust areas. That 4 thrust areas are, the first one is powertrain, then second one is chassis and safety, third one is cabin and comfort, and the fourth one is infotainment and telematics. The entire automotive system we can classify it into 4 main thrust areas. So first one, that is in powertrain, chassis and safety, cabin and comfort, and infotainment and telematics. So these are all controlled by a large number of electronic control units, that is called as an ECUs, that are operate simultaneously and are not networked with the several CAN bus systems. So individual systems, for example, if it is an powertrain unit. So individual powertrain unit, it has their own ECUs. That ECUs includes an microprocessor and microcontrollers. That microprocessor and microcontrollers that controls the ECUs. The ECUs based on the sensorical outputs that controls the entire systems of powertrain unit. Likewise for the chassis and safety, cabin and comfort and infotainment and telematics. Each and individual systems has their own ECUs for controlling their own systems. All the ECUs and sensor outputs are controlled and connected by means of CAN networking systems. So that only all the systems, all the ECUs which get an uniformed data, uniformed output as a single unit. So for example, if the wheel speed sensor that measures in wheel speed, that wheel speed signal is used for several applications. For like an ABS, it need an wheel speed, and the electronic stability program, it need an wheel speed, and for an infotainment like in the speedometer, it needs to showing that wheel speed. Traction control system, it needs an wheel speed. So it cannot be given for all those things. As a single output of CAN systems, controlled area network, it will be given. Wherever it requires, it will get from the output. As these kind of assistance systems also mean additional input for control of driving dynamics, they usually require an optimization of the architecture in order to obtain an economical control and a greater complexity. Right? It is an example of decentralized electrical and electronic architecture. So here it is showing that an 4 main thrust areas of automotive electrical and electronic systems. The first one is powertrain domain, second one is chassis and safety domain, third one is cabin comfort domain, fourth one is infotainment and telematics domain. The first one is powertrain domain. So on this powertrain domain, it is a power producing medium. So on this power producing medium, so what are the electronics included in this powertrain unit? The first one is like an engine management system. So on this engine management system is a separate part, because for controlling, for getting an optimal output from the engine, for obtaining a maximum of power like that, as a human to machine interface like that, as we are giving an acceleration, how the machine can able to understand that everything is connected by means of drive-by-wire technology. So how the machine can able to understand the driver's requirement, everything is by means of like an sensor outputs, actuators and ECUs that is interconnected with that as an CAN networking systems. So it has some neural network connection in between that. So like an engine, as a driver requirement, as a driver gives an acceleration, how the machine can able to understand that. So like it has a varieties of sensors that are included, like in mass of airflow sensors, map sensors, like in pressure sensors, temperature sensors, positioning sensors, all the sensors, like it has a varieties of operations. So all are mounted based on their requirements. So these sensor inputs are given to the respective ECUs. So the engine management system has their own ECU for controlling the engine power and engine output. So that includes a variable valve timing technology. If suddenly accelerating means, so the valves are which are open earlierly, so that has a separate thing, and like a variable geometric turbine, like in turbochargers. So whenever requires, so the turbo boost will be operated. So this will also include for improving the engine power, then spark in advance. So if you are suddenly accelerating that vehicle nowadays, so the power is getting in an instant of time. How is it possible now? Spark advances. So how they are making in spark advances? By getting a signal output from the throttle position sensor. So based on that, they are advancing the spark advance, like in DDIS and other parameters are there. Then CRDI, like in this CRDI, common rail direct injection systems, ignition advance is there. And various sensors, they are located for driving this CRDI systems for the controlling the engine power, and we are getting an optimal power and mileage. And other than that of engine management system, the next is an emission. So on this emission, so nowadays we are following BS6 norms. So BS6 norms means emission after treatment. So on this after treatment means after the combustion, the emission will be treated as an harmful to harmless gases. That includes a catalytic converter function. So when the catalytic converter starts to function after 200 to 250 degrees Celsius, So this function can be also an does by means of an electronics, like an heater is provided for that, and O2 sensor is provided for that. It is a part of electronics and sensors. And nowadays we are introduce an SCR also, selective catalytic reduction. They are injecting ammonia into this, so for reducing the exhaust emission. So this is a big role for the engine management system. Other than this, like it is having a body builder, brakes, retarders, gearbox. Like in this gearbox is a separate part. So in this gearbox, like we have an automatic transmission systems. So on this automatic transmission systems, everything that is an automated. So we just put an we just give an information to this vehicle as an given acceleration. So based on acceleration driver's requirement, that changes the gears. So like we have an DCT, dual clutch transmission system is there. Then continuously variable transmission CVT is there. That includes an torque converter function also. Then AMT, automatic manual transmission. So it is semi-automated like functions. Automatic AMT is there. Then IMT, intelligent manual transmission is there. Okay. So all those automatic transmission, that includes an automatic transmission based on our requirements, that changes the gears. So how it will changes the gears? Now inside that it has an epicyclic gear train. On this epicyclic gear train, the functional operation, like so it needs to apply and brake, and it needs to changes the gears. All those functions should be carried out by means of an electronics, like an electromagnet braking systems, everything that included in this part. And not only for this, as a differential function also, limited slip differential is there for avoiding the slip on the wheels. So limited slip differential also will be operated by means of electronics. As a mechanical component is a major, but it will be controlled by means of an electronics. So electronic differential is there. Then second part is like an chassis and safety domain. So on this chassis and safety domain as a control unit, these two also have a separate ECU. So like a level and roll control, tire pressure monitoring, battery and energy management system, advanced driver assistance system, body building systems. So that are included as a chassis, like anti-roll. So for controlling the vehicle stability, anti-roll systems is there, and for a braking system, anti-lock braking systems to avoid an skidding action and to get a directional stability, electronic stability program that stabilizes the vehicle when it is sudden cornering occurs. So when the sudden cornering during high speeds, the electronic stability program will control the stability of a vehicle, and the electronic brake force distribution based on the load carrying capacity and load distributions that distributes the brake force to the front and rear wheels, not only for the front and rear wheels, so for all the four wheels also. Then traction control system for getting in grip, road grips, for better road grips on the slippery areas, traction control systems that are used, hill hold assist. So if the vehicle is in a slope area, so if you are stopping this vehicle, then if you are suddenly accelerating, so that avoids coming down in this slopen area, that will holds the vehicle, hill hold assist. Then center of gravity measurement, that is a vehicle positioning sensors, like term to be as an G sensor, that measures the vehicle positions. Based on that, that maintains the stability of the vehicle. Then intelligent power transmission, that means, so based on driver's requirement, whether if it is equipped with the all-wheel drive, four-wheel drive mechanism means, so if the vehicle is running normal city drive means only front wheels will get in more power. If we need an sports mode means like an power, if we need a more thrust areas, in those conditions, so what happen means, so the based on requirement, thrust requirement on this, so it will distributes the power to required area. If the sports mode is enabled means, so the more power will be delivered to the rear wheels, then only we can able to get a more thrust force on this. In normal mode, we need an economical way of driving, so the front wheels only getting in more power. So that has to be done by means of intelligent power transmission. Then vehicle power to weight ratios, this includes a part of this. So if you are applying brake, so 60-40, like in frontal side, it gives an 40% of weight, and rear side it has an 60% of weight. While applying brake, it will be equalized 50-50. Like this distribution also will comes under this and chassis part. And other than this, so like in suspension systems, nowadays on suspension systems we have an air suspension systems as an individual suspension is given for the independent suspension, like an air suspension is given for all the four wheels. So additionally they are equipped with the hydroelastic suspension for getting a better comfort of driving and for maintaining low profile, that is a low ground clearance. It is possible by means of hydroelastic.
With this, we can conclude our today's video lecture now. The remaining will be discussed on the next video. Thank you.